Hello. So now that we have keyframes from the last video, we're going to take those and I'll show you how to use OCR technology to extract the pages. Alright, so here's our notebook. We got sort of our standard imports. You probably haven't seen the glob function before. That's just a way to get a bunch of files in a directory. This is saying get me all the files ending in PNG in the pages directory that we saved to in the last video. And it's kind of nice. Got 3 images. We can draw a frame. I put the draw frame function from the last video in a utils file. And yeah, there's the frame. Next up, we don't need color for OCR, so we're going to do grayscale. It'll be a lot faster to run. And same code as last time. Now here's just a blurb I wrote. I would recommend using some of the big company APIs for OCR. We're going to evaluate Textract and Microsoft in this video. And we'll actually end up with Microsoft because their output's a little bit better in this case. A lot of people in a lot of videos use Textract, but in my experience, it's really not good. It's slow. And even if you do find you like Textract a lot and you have to pay, it's worth it. It's pennies. I mean, for most cases, I do strongly believe it's worth it. Maybe your own circumstances or for your use case, Textract will work, but try out the paid ones. They're good. Also, Microsoft does have a free tier that should work for you too, and I highly would recommend that. Okay, so I've created a template file like I do in all my videos where I sort of say, here's how you get the keys, put them in here, copy it to secretservices.py, and then you'll be good to go. So that's what secret services is. I'm not going to show you that because it has my own keys in there. Okay, so to work with Textract, this is how you have to manipulate the image. It likes things in this bytes format. Also, if you're to open up an image, like a PNG image in a text editor, this is what you would see. And that's how you generate it. So we're just going to use Textract to detect the text right now. All right, we got our response. Now we're using TRP. This is a Textract response handler. It's kind of nice for dealing with Textract output. Okay, so what I'm doing here is a list comprehension to find me first all the pages and then all the lines on those pages. I believe we just have one page, so it's not a big issue. I did add an exception just in case somehow we got multiple pages back. And I'm printing out what the text of the lines is. So it starts off with division of labor. To take an example, therefore very truly manufacture. I do have the book, but first let's take a look at sort of orienting the text better, because it doesn't look like I've extracted how there are 2 pages. Notice there's a left page and a right page, so we need to sort of group our text appropriately. So I'm going to do that first here. Okay, so here we're just doing a histogram of the leftmost part of the bounding box. When OCR runs, it will create, it'll give us back the coordinates of each word that was detected. So we're just saying, give me a histogram of each leftmost part of the lines of the OCR text. So I can see there's sort of a few different clusters here. One here, one in the middle, and the one on the far right. Presumably that far right could be like that text or like a number or something. So we're going to sort of break it up into those 3. Here we go. If you use the actual histogram code yourself, you can extract the frequencies of the values. And here they are again. I use a different number of bins because in my head, breaking up 2 pages into sort of 3 components each made a lot of sense. You have a left bit, a middle left bit, and then like a left middle, or sorry, left left, left middle, left right, corresponding to left left, left middle, left right. That's sort of how I went about it. And here's what that histogram looks like from a numerical standpoint. And this is an algorithm, I do very well believe it works, to find consecutive values. So if we had 31 followed by 1, it would sort of say, here's where that sequence starts, here's where it stops, including the first one, not including the second, is how we'll sort of use it. And you'll see this 37 and 7 are both being mapped to the same group. So that's kind of what we're doing here. We're creating different line segments from our set of lines. Nope, I gotta rerun that. Okay, not the most verbose here. They don't have a good visualizer with the Textract package, but we will just print it out ourselves. We're going to go through each set of group lines and see how that compares. So book 1 of the causes of the improvement in the productive powers of labor in the order according to which its produce is naturally distributed among the different means of the people. Mix of the people, produce. So that looks pretty good so far. But then as I kept looking here, I saw some scrambling. Which others are people, small one, that's in the small number destined, whole number of workmen. See how things aren't really lining up right? That was kind of unfortunate. I was a little surprised by that performance. When I looked at it a little bit deeper, I saw some issues with like the bounding boxes and the angling and the sorting, and also just some words were missed. Again, a little bit surprised, and it made me a little saddened or disappointed because if that's not good enough, we need to go back a video and make our keyframes better so that OCR can handle it. So then next up, I went and used Microsoft Read API. And somewhat similar to Textract, you have to use bytes and all that, but Cliff Notes is Read API works much better, and that's what we're going to use in these videos. Here's how you set it up. Let me know if you run into issues. Add your credentials to the secret settings or secret services file. Okay, so here's how you submit things to Microsoft. Notice it has this nice reading order. So whereas Textract didn't really give us everything in order, we created some fancy algorithm to sort of order things. Microsoft will actually give you the option to sort it like you would do in English. I haven't tested like Arabic if it goes the other way or not, but definitely English works pretty well. So just be sure to use that argument when you use Microsoft. Here we go. We're submitting a request. Now this is just code. I believe I found this actually on the Microsoft website. That's what it's sort of based off of. I changed this to be a little bit nicer, but yeah. So what happens is you sort of submit the request and it works asynchronously. It doesn't, hold until it's finished. You don't have to wait. And then what you're supposed to do is just check if it's done. So I'm saying while the job is still running, wait 3 seconds, try again until it's no longer running. So we finished the response. We don't know if it failed or not yet, but here I do see succeeded. That's great. And here's what that raw output looks like. You can see there's a bounding box. These are all the different corners of the box. So 1, 2, 3, 4, 5, 6, 7, 8. So, X, Y, X, Y, X, Y, X, Y, four coordinate pairs there. And then you have the various text, so lines, and I believe they also have words. Yep, here's words. So all we're going to do is same thing as we do with Textract. We're going to print out the results. Looks pretty much the same, but the big difference now is you don't see any more of those short little stubby phrases where Textract kind of messed up or our grouping messed up. There is this not a number here. I believe that was like the page number on the right side. So it wasn't really an issue when I looked. But overall, this looks good enough for me to move to the next step where we're going to use Project Gutenberg and the already transcribed version of the book to see how accurate our OCR is, because looking line by line after a while is a little tiresome, and it's good to use more automated results. Also, I want these tutorials to be somewhat realistic. I don't want to show you the happy path of everything working perfectly. AWS didn't work, so we quickly tried another API. That's a skill you have to be pretty good at with programming. Just try things. Don't get too caught up in the docs and what people claim they can do. Just run it, especially if it's not too hard to do. Try to get good at that so you can quickly evaluate things and see how well they work for you. And now we can even test Textract later and Microsoft if either one of them improves to see if we want to switch between one and the other. But in our case, we're just going to roll ahead with Microsoft. Now here's just some functions to turn this into a function we can run more repeatedly, a little bit easier to reuse with all the images we have to use. In my video, I just did a quick 4-second split. That was because I wanted to be able to upload the example video to GitHub. But if you're running 200 images through this, it's nicer to use a function and sort of see the output as I'll do below. So same code as above, pretty much, extracting the lines. It's already ordered because we have reading order natural set. Putting that in there. And now we're doing our TQDM, giving us a progress bar of getting the lines for each image. This should take, I think, let's see, 25 seconds. Right, 25 on the money. Just barely though, 8.34 seconds for iteration. Anyways, here's our page lines. This is pretty good. We're going to move on to the next notebook, next video to evaluate things. First, let's just save things. Here's my pages directory, text file. Boom, so we can see there's our saved text. All right, thanks for watching.